So now we will discuss about the alkenes and alkyl radicals. So you can say alkanes are hydrocarbons that contain only single covalent bond between carbon atoms are called alkanes. Alkanes are saturated hydrocarbons. These hydrocarbons are also called paraffins, which is a Latin word meaning little affinity. These hydrocarbons are less reactive due to their saturated nature. तो यहाँ पर मैं अल्केन्स के बारे में हम कहेंगे कि अल्केन्स क्या होते हैं. तो ये क्या अल्काइंस जो है ये हाइड्रोकार्बन्स हैं जिसमें सिंगल बॉन्ड होते हैं सिर्फ कार्बन एटम्स के दरमियान में. यानी अल्केन्स वो हाइड्रोकार्बन्स हैं जिसमें कार्बन एटम्स के दरमियान में सिंगल बॉन्ड होते हैं. और अल्केन जो है ये सेचुरेटेड हो यानी हाइड्रोकार्बन्स होते हैं. इनको हम पैराफिन्स भी कहते हैं क्योंकि पैराफिन्स का मतलब है लिटिल एफिनिटी. So it has little affinity towards other compounds. So these hydrocarbons are less reactive due to their saturated nature. ये चूँकि saturated होते हैं तो लिहाजा ये जो है less reactive होते हैं. Now we can say the group of compounds comprises of a homologous series with a general molecule formula. We can say this is the Cn 2n plus 2. So you can say this 2n plus 2. So we can say the formula CnH2n plus 2. So this one N stands for number of carbon atoms in the alkanes. So we can say here is shown the number of carbon atoms, the general formula. We can say this formula, according to this, say number of carbon atoms, if 1, so it will have 2 C1H 2n plus 1. So you can say, so it will have, if we put the value of n 1, so we will get, so we can say that if we put the value of 1 and 1 h is 2n, 2 into 1 plus 2, so that will be equal to C1 H 2 plus 2, and it will be equal to C1 H4, or you can say that will be equal to CH4. So this will be the methane. So it is shown here the formula of so using this formula we can determine the at the base of number of carbon atoms we can determine the formula. So similarly, if we have so this is the methane. So similarly, if we have 2 carbon atoms, so we put the number of carbon atoms in this formula. So we can say, so we will get C2, you can say H2 by 2 plus 2, and that will be equal to C2 H6, that will be 10. Similarly, if we have 3 carbon atoms, we will get put the value of N, which is 3, so we will get C3H8, which will be propane. Similarly, for 4 carbon atoms, we have 4 C4H10, which will be butane, and with the pentane 6N with the carbon 5 and 6. So having formulas C5H12 and C6H14. So in this way you can determine the formula on the basis of number of carbon atoms. So these are also the, you can say 10 carbon atoms having decane, and 9 carbon atoms nonane, 8 carbon atoms octanes, and heptane is having 7 carbon atoms, and you can say C7, C7H16, and C8H18, C9H20. So if you closely examine the molecular formula for successive alkanes, table 11.2, you will see a clear pattern. Each number of the series differ from the preceding one by 1 carbon atom and 2 hydrogen atoms. For example, propane differ from ethane by 1 carbon atom and 2 hydrogen atom. methylene ग्रुप। तो ये बता रहे कि जो हमारे पास प्रेसिडिंग जो नंबर जो मेंबर्स आते हैं, यानी अगर हमारे पास यहाँ पर एग्जांपल दिया गया है कि जिस तरह प्रोपेन है वो उसमें यानी एक कार्बन डिफरेंट होगा, यानी एक्स्ट्रा होगा, और 2 हाइड्रोजन एटम एक्स्ट्रा होंगे। जैसे कि प्रोपेन इथेन का फार्मूला जो है C2, you can say C2H H6, so you can say this is 6, and propane is having formula C3H8, C3 you can say C3H8. So these two compounds different by 1 carbon atom and 2 hydrogens. Because you can say that it's a 2 carbon, it's a 3 carbon, so 1 carbon is extra in case of propane, and this is 6 hydrogen, it's 8 hydrogens. So the hydrogen atom is 2 extra in case of propane. So you can say that each member of the series differ from the preceding 1 by 1 carbon atom and 2 hydrogen atoms. For example, propane differ from ethane by 1 carbon atom and 2 hydrogen atoms. So this is the ethane, we can say, having 6 carbon atoms, and this is the propane having 8 carbon atoms. So you can say that these 2 hydrogens and 1 carbon is extra as compared to the ethane. So next one is naming of alkanes. Simple straight chains alkanes can be named by the following rules. Count the number of carbon atoms in a formula of an alkane. The first 4 alkanes are named methane, ethane, propane, and butane. For higher alkanes, write the prefixes of Greek numerals. You can say pent, hex, hept, for 5, 6, 7, and so on. End the names by writing in to the Greek numerals. तो ये बताते हैं कि जो हम नेमिंग कैसे करेंगे अल्केन्स की। तो नेमिंग करने के लिए सिंपली उसमें नंबर ऑफ कार्बन्स को काउंट करें कि नंबर ऑफ कार्बन्स कितने हैं। तो द फर्स्ट 4 अल्केन्स नेम, तो उसके बाद फिर जो यानी अगर एक कार्बन है तो वो मीथेन होगा, और दो कार्बन अगर है तो इथेन होगा, और 3 कार्बन है तो प्रोपेन होगा। सो इसके अलावा जो ज़्यादा होंगे वो फिर उस हिसाब से फिर यानी कि मीथेन में क्या, ये मेरे पास मीथेन है, इसमें 1 कार्बन होगा। सो सिमिलरली इथेन में 2 कार्बन होंगे, 1 कार्बन 2 कार्बन। प्रोपेन में 3 कार्बन है, और ब्यूटेन में 4 कार्बन। सो इसी तरह जो बाकी है यानी पेंटा 5 कार्बन है, हेक्सा 6 कार्बन है, हेप्टा 7 कार्बन। सो इसी तरह 5 6 7 एंड सो ऑन। तो आखिर में जो एन द नेम बाय राइटिंग एन, आखिर में नेम के पीछे एन लिखना है। तो इनसे जिस तरह मीथेन के पीछे आखिर में एन है, दिस इज द एन, वी कैन से this is the N, and this is the N also. In case of ethane, in case of propane, N, finally is N, this is butane is N, or similarly for higher, you can say pentane, hexane, pentane. So finally, you can say N, you can write N. So this is the naming of alkanes. So here we can see that organic compounds composed of carbon and nitrogens are called hydrocarbons. यानी वो compounds जिसमें कार्बन और नाइट्रोजन होता है उसको हम organic compounds कहते हैं। Now next one is homologous series. So what is homologous series? It is a series of organic compounds that have similar structure features but differ from adjacent members by CH2 group is referred as a homologous series. होमोलोगस सीरीज के ये ऑर्गेनिक कंपाउंड्स की एक सीरीज है जिसमें सिमिलर स्ट्रक्चर फीचर इनके होते हैं। जो ऑर्गेनिक कंपाउंड्स हैं उनके स्ट्रक्चर फीचर सेम होते हैं, लेकिन जो बट डिफर फ्रॉम एडजेसेंट टू मेंबर्स, लेकिन जो एडजेसेंट मेंबर उनसे CH2 ग्रुप के जरिए से डिफर करते हैं, तो उसको हम कहते हैं होमोलोगस सीरीज। So you can say each member of the homologous series is called homolog. A general molecular formula can be used to determine the formula of the whole series. यानी कि जो होमोलोगस सीरीज है तो उसमें सीरीज ऑफ कंपाउंड्स होते हैं जो कि स्ट्रक्चर फीचर में सेम होते हैं, लेकिन एल्काइल ग्रुप के ज़रिए से एक दूसरे से मुख्तलिफ होते हैं। तो ये जो अल्काइल ग्रुप के ज़रिए से मुख्तलिफ होते हैं। सो नेक्स्ट जो होता है उनसे मेंबर होते हैं उनसे मुख्तलिफ होते हैं। इसके बाद एक कैरेक्टरिस्टिक्स ऑफ होमोलोगस सीरीज, you can say they have same general formula, they have similar chemical properties because they have the same functional group each member different from the previous one by methylene group. They have similar method of preparation to जो homologous सीरीज होते हैं उनका सेम जनरल फार्मूला होता है और सिमिलर केमिकल प्रॉपर्टी होता है क्योंकि इसका फंक्शनल ग्रुप जो है वो सेम होता है। तो हर मेंबर जो होता है पहले से मिथाइल ग्रुप के ज़रिए से डिफरेंट होता है और इसके अलावा इसका जो प्रिपरेशन मेथड है वो भी सेम होता है। इसके बाद साइक्लो alkanes. Cycloalkanes are alkanes in which the carbon atoms are arranged in a ring or cyclic structure. Cycloalkanes वो alkanes है जिसमें जो कार्बन एटम है उसको साइक्लिक स्ट्रक्चर के ज़रिए से हम अरेंज करते हैं दूसरे से अरेंज होता है, यानी कि साइक्लिक अल्केन्स में उसमें फ्री कार्बन नो देयर आर नो फ्री एंड कार्बन, यानी जो कार्बन एंड वाला होता है वो फ्री नहीं होता। सो वी कैन से इन द ओपन चेन अल्केन्स द फ्री एंड कार्बन एटम्स आर अटैच्ड टू 3 हाइड्रोजन ग्रुप्स, यानी जो आखिरी कार्बन होते हैं वो फ्री नहीं होता बल्कि उसके साथ 3 हाइड्रोजन लगे होते हैं। Cycloalkanes have 2 less hydrogen atoms than the corresponding straight chain alkanes. तो cycloalkane में उसमें 2 हाइड्रोजन कम होते हैं चेन में, यानी नेक्स्ट जो आ रहा होता है उनसे 2 हाइड्रोजन कम होते हैं जो स्ट्रेट चेन में आ रहा होता है। मिसाल के तौर पर ये जो साइक्लोब्यूटेन है इसमें 2 हाइड्रोजन लेस, 2 less hydrogen atoms than non-cyclic butane. तो cyclobutane जो है, if we see the formula of the cyclobutane and we can say this is cyclic butane and this is a non-cyclic butane. So what have formula? We can say C4H8. So C4H8, we can say this is cyclic butane H8, and non-cyclic has formula C4H10. So we can say that this one has 8 hydrogen and this was 10 hydrogen. So 2 hydrogen atoms are extra in cyclic butane is compared to in non-cyclic butane is compared to cyclic butane. So you can say that cyclic butane has 2 hydrogen less than non-cyclic butane. So this is a structure given. We have butane, this is cyclobutane, and this is a non-cyclobutane. So you can say that in case of cyclobutane, if we count the number of hydrogens, you can say this is 2, 4, 6, and 8. The carbon atoms are 1, 2, 3, 4. So you can say the formula will be 4 carbon atoms C4H 2468. So this is cyclobutane. And in case of non-cyclobutane, if we count the number of hydrogens, we can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 hydrogens and 1, 2, 3, 4 carbon. So in case of non-cyclic butane, we have 4 carbon, and hydrogen 10. So 10 hydrogen. So we can say, so in this case, we can say that 2 hydrogen, it's a 10 hydrogen, it's a 8 hydrogen. So in case of cyclic butane, 2 hydrogens are less as compared to non-cyclic butane. So the structure formula for cycloalkanes are often drawn in a simple polygons in which the side represent the carbon-carbon bonds. It is understood that each corner of the polygon is a carbon atom bonded to 2 hydrogen atoms. So you can say that this is the cyclopentane and this is the cyclopentane. So we can say that CH 1, 2, 3, 4, 5 carbons and having 2, 4, 6, 8 and 10. So in case of cyclopentane, you can say that there are 5 carbons and hydrogens are 2, 4, 6, 8, 10. Hydrogens are 10. And in case of cyclopentane, so this is the formula of cyclopentane. We can say that the structure formula for cycloalkanes are often drawn in simple polygons in which the sides represent the carbon-carbon bonds. It is understood that each corner of the polygon is a carbon atom bonded to 2 hydrogen atom. So if you see that each carbon, in this case each carbon is bonded with 2 hydrogens. So you can say this is a carbon bonded with 2 hydrogen, this is a carbon bonded with 2 hydrogen, this is a carbon bonded with 2 hydrogen, and this is a carbon attached with 2 hydrogen. So this is a polygon, you can say, in which each carbon is attached with 2 hydrogen atoms. So next one is, you can say, alkyl radicals. So alkyl radicals, what are these? Alkyl radicals are a group of atoms that are formed when the hydrogen atom is removed from the alkene molecule. When one hydrogen atom is removed from the alkene molecule, for example, you can say that if we have alkane, in case of you can say this is methane, it's alkane. If we remove one hydrogen from methane, so we will get minus H, so we will get CH3. So this is the, you can say, this alkyl group. So when one hydrogen atom is removed from alkane, it becomes alkyl radical. So this is the alkyl radicals because we have removed one hydrogen from alkane. Alkyl radical is represented by general letter R. We can say that this can also be written as R. So C3 can be written as R. The name of the alkyl radical is derived from the name of the corresponding alkanes, in which the last N of alkane is replaced by YL. So the general formula of alkyl radicals is you can say CnH2n plus 1, where N stands for the number of carbon atoms in the alkyl group. So we can say this is the alkanes. If we remove the one hydrogen, I can say it will become alkyl. So by removing hydrogen atom, you can say by removing N, we will get YL. This will become alkyl. So this is the example. This is alkane, and we have removed hydrogen, and this will become alkyl. So we can say that this is the alkyl, and this is the alkyl, and this is the alkane, this is the alkane. So we have removed one hydrogen atom minus. So we can say we have removed N, become YL, we can say become alkyl. So this one's, this one. Now this is the table, names of molecules, molecular formula of alkanes and their respective alkyl radicals. Methane, formula CH4. So consists of one carbon atom. Since ethane has two carbon atoms, propane has three carbon atoms, butane has four carbon atoms, and pentane has five carbon atoms. So methane have one. If we see formula 2n Cn H2n plus 2. So in place of n, we will put the number of carbon atoms. So from this we will get for one carbon atom, we will get CH4, and if we remove one hydrogen from, you can say from methane, we will get methyl. You can say methyl, and this is the alkyl radical. Similarly, if we have two carbon atoms, so and we put the number of carbon atoms in this formula, so we will get C2H6, and if we remove one hydrogen, so it will become ethyl C2H5. So, and if we have three carbon atoms, you can say, so this will be propane and having formula C3H8, and if we remove one hydrogen, it will become propyl C3H7 propyl. Similarly, butane, you can say, remove hydrogens, it become butyl, and in the same way, pentane will become pentyl. So this is the molecular formula of alkanes and their respective alkyl groups. Now next one is, you can say, functional groups. Functional groups. A functional group is an atom or a group of atoms attached with R that is responsible for the specific properties of an organic compound. तो फंक्शनल ग्रुप है, ये क्या चीज़ है? फंक्शनल ग्रुप ये क्या होता है? ये एटम या ग्रुप ऑफ एटम्स होते हैं जो आर यानी कि के साथ अटैच होते हैं, जो किसी कंपाउंड की जो स्पेसिफिक प्रॉपर्टीज है उसकी उसको मुतय्यन करता है, उसको बताता है. We can say, in other words, we can say that the reactive portions of the molecule containing other elements is called the functional group. यानी कि जो रिएक्टिव एक मॉलिक्यूल का जो रिएक्टिव पोर्शन होता है, जो रिएक्टिव हिस्सा होता है कंटेनिंग अदर मॉलिक्यूल, उसको हम कहते हैं फंक्शनल ग्रुप. तो द बॉन्ड्स विद इन द फंक्शनल ग्रुप आर यूजुअली द साइट ऑफ द केमिकल रिएक्शन. Once the functional group of an organic compound is identified, then most of the properties of that compound and the preparation of that compound can easily be understood. All compounds that contain the same functional group have similar properties and can be classified together in the same homologous series. The remaining part of the molecule determine the physical properties such as melting point, boiling point, and density. तो ये बता रहे कि ये जो अल्काइल ग्रुप है, यानी कि जो बॉन्ड बनता है, बॉन्ड फंक्शनल ग्रुप के दरमियान में जो बनता है, द बॉन्ड्स विद इन द फंक्शनल ग्रुप्स आर यूजुअली द साइट ऑफ द केमिकल रिएक्शन. तो वो बेसिकली क्या होता है, वो केमिकल रिएक्शन की साइट होती है जहाँ पे केमिकल रिएक्शंस हो जाती है. अगर हम किसी कंपाउंड की जो फंक्शनल ग्रुप है उसको मालूम करें, तो फिर हम उस कंपाउंड की जो प्रॉपर्टीज उसके बारे में पता लगा सकते हैं कि उनकी प्रॉपर्टीज क्या है. इसके अलावा उसकी प्रिपरेशन का भी पता लगा सकते हैं कि वो कैसे तैयार होता है. तो ऑल कंपाउंड्स, यानी वो कंपाउंड जिसके फंक्शनल ग्रुप हो सेम होती है, उनकी प्रॉपर्टीज भी सेम होती है, और उसको हम सेम होमोलोगस सीरीज में क्लासिफाइड करेंगे. लेकिन से इसको तकसीम करेंगे, यानी फंक्शनल ग्रुप जो है ना, उसकी जो प्रॉपर्टीज है कंपाउंड की वो मुतय्यन करती है, और उसकी जो प्रिपरेशन है उसको हम भी पता लगा सकते हैं. तो इसके अलावा जो रिमेनिंग पार्ट होता है मॉलिक्यूल का, वो फिजिकल प्रॉपर्टीज को मुतय्यन करती है, जैसे कि मेल्टिंग पॉइंट है, बॉइलिंग पॉइंट है, डेंसिटी. तो यहाँ पर organic compounds are composed of two parts: the hydrocarbon part, which is alkyl group, you can say the functional group. तो ऑर्गेनिक कंपाउंड जो होते हैं वो दो हिस्सों पर मुश्तमिल होता है, एक अल्काइल ग्रुप होता है और एक होता है फंक्शनल ग्रुप. तो ये दो पार्ट होते हैं. तो जो फंक्शनल ग्रुप है वो उसकी प्रॉपर्टीज को डिफाइन करता है, यानी फंक्शनल ग्रुप है वो प्रॉपर्टीज को डिफाइन करता है. और जो प्रॉपर्टीज जो दूसरा होता है अल्काइल ग्रुप, वो उनकी जो बाकी फिजिकल प्रॉपर्टीज है, जैसे मेल्टिंग पॉइंट है या बॉइलिंग पॉइंट है, ये उनको, या जो डेंसिटी है उनको बताते हैं. तो किसी ऑर्गेनिक कंपाउंड के दो पार्ट होते हैं, एक अल्काइल पार्ट होता है और एक फंक्शनल ग्रुप पार्ट होता है. फंक्शनल ग्रुप जो है ना वो यानी कि प्रॉपर्टीज ऑफ दैट कंपाउंड को मुतय्यन करता है, और इसके अलावा जो बाकी जो रिमेनिंग पार्ट है, यानी कि जो you can say the alkyl part of functional group properties. So here we have seen all compounds, you can say that here we have seen that once the functional group of the organic compound is identified, then most of the properties of the compound, the preparation of the compound is easily understood. तो जब हम किसी फंक्शनल ग्रुप को पहले मालूम करें, तो इसके बाद फिर हम उस कंपाउंड की जो प्रॉपर्टीज उसको आसानी से मालूम कर सकते हैं। तो वो कंपाउंड जिसका फंक्शनल ग्रुप सेम होते हैं उनकी प्रॉपर्टीज भी सेम होती है, तो और वो सेम होमोलोगस सीरीज में फॉल करते हैं। तो यहाँ पर ये अल्काइल ग्रुप है और ये फंक्शनल ग्रुप है। तो ये मेथनॉल है, दिस इज methanol. You can say this is a methanol having formula CH3OH. So in this methanol, you can see this organic compound has two parts. One is a CH3 part and the next one is OH part. So this is the CH3 part and this is the OH part. So OH part is a functional group and the CH3 is the alkyl group. So you can say table represent the organic compounds containing methyl radicals attached to the different functional groups. So this is a table. So this is functional group OH, and in general formula you can say this is alkyl group and having functional group OH, and this class will be alcohol and having formula CH3OH, and the name of that compound will be methanol. Similarly, if we have functional group of CHO, so it will have, if we attach the alkyl group with the CHO, so it will have general formula RCHO, and that will be the aldehyde class. So CHO is of aldehyde class, and its formula will be CH3CHO, and we can say this will be ethanol. Similarly, the functional group of CO, we can say this is attached with two alkyl groups. So this is a ketone CH3COCH3, and this is the name will be propanone. Similarly, if we have a functional group of COOH, it will have one alkyl group attached with COOH, and that will be carboxylic acid, and having formula CH3COOH, and we can say it will be ethanoic acid. Similarly, if we have a functional group of NH2, and it will have one alkyl group, and it will be, you can say, of class amines. So C3NH2, so methylamine. Next one is, you can say, -6, so R -6 will be alkyl halides, just like CH3Cl, and it will be methyl chloride. So these are the functional groups attached with alkyl groups. So similarly, we can say, based on the functional groups, so the organic compounds are divided into the following groups. Functional groups containing carbon, hydrogen, and oxygen. So functional groups containing carbon, hydrogen, oxygens. The organic compounds containing carbon, hydrogen, oxygens as a functional groups are alcohols, ethers, carbonyl compounds, or you can say groups, aldehydes, ketones, carboxylic acids, and their derivatives such as esters, acid halides, and acid amides. तो ये बता रहे कि जो फंक्शनल ग्रुप्स है जिसमें कार्बन, हाइड्रोजन और ऑक्सीजन होते हैं, तो वो ऑर्गेनिक कंपाउंड्स जिसमें कार्बन, हाइड्रोजन और ऑक्सीजन होते हैं एज ए फंक्शनल ग्रुप, तो वो कौन कौन से होते हैं? वो अल्कोहल की सूरत में होते हैं, ईथर्स की सूरत में होते हैं, यानी ये ऑक्सीजन है, ये हाइड्रोजन है, तो ये इसके अलावा कार्बोनाइल कंपाउंड्स, अब इसमें यानी कि कार्बन भी है और ऑक्सीजन भी है, और ग्रुप्स यू कैन से aldehyde, ketones, and carboxylic acid, carbon, oxygen, and hydrogen. So this is the carboxylic acid group, and their derivatives such as esters, acetylides, and amines. Now we can say the alcoholic functional group. The functional group of alcohol is OH. So OH is the functional group of alcohol. The general formula of alcohol is ROH, where the letter R represents the alkyl group in the organic compound, and OH is the functional group of the alcohol. So you can say this ROH will be, so this we have already discussed that this is the alkyl group and this is the functional group, and this is the functional group which is alcohol. So you can say that alkyl group R, which is we can write CH3 and C2H5, and if we take the functional group, we can say that CH3OH. So in this case, this is the functional group OH, and this is the alkyl. We can write this the same, just like this, ROH. So this is the methyl alcohol. Similarly, C2H5 OH, and we can say C3CH2OH. This is ethyl alcohol. Now, so the next one is ether functional groups. Ether. So the functional groups of ether is you can say O on both sides having alkyl groups. So we can say since the functional group is O, so it means that this ether will have R on both sides. So the general formula of ether is ROR, where the letter R represents the alkyl group in the organic compound, and this O represents the functional group of ether. So this is the functional group of ether. We can say this is the ether, and this is the alkyl group, which is this one. This is the alkyl. This is the alkyl group, and this is the ether group. So now this is, I can say, the ether group and having on both sides alkyl groups, which is ROR. So the formula will be CH3, and CH3 this is alkyl group and group of ether functional group. So this is a dimethyl ether. Similarly, ROR, you can say C2H5OH and OCH3 ethyl methyl ether. So now this is given that functional groups identification test, aldehyde, ketones, carboxylic acid, phenols, amines. Now next one is the carbonyl compounds. Carbonyl group is a functional group composed of a carbon atom double bonded to oxygen atom. So this is a functional group. A compound containing a carbonyl group is often referred to as carbonyl compound. The general formula for the carbonyl compound is R C double bond OR. These compounds are further divided into aldehydes and ketones. So we can say aldehydes, the functional group for these organic compounds is the carbonyl carbon. In this organic compounds, the functional group is bonded with hydrogens on one side and carbon on the other side, for example. So this is the formaldehyde and this is the acetaldehyde. So I can say that aldehyde इसमें जो होता है फंक्शनल ग्रुप जो होता है इसमें कार्बोनाइल कार्बन होता है फंक्शनल ग्रुप। तो इस ये जो ऑर्गेनिक कंपाउंड्स है इसमें फंक्शनल ग्रुप हो एक तरफ से हाइड्रोजन के साथ अटैच होता है, जैसे ये हाइड्रोजन के साथ अटैच है एक तरफ, और ऑन द अदर साइड with the carbon and one side hydrogen on one side and carbon on the other side, दूसरी साइड से ये कार्बन के साथ अटैच है। तो ये जो फंक्शनल ग्रुप है एक तरफ से ये हाइड्रोजन के साथ अटैच है, दूसरी तरफ से कार्बन के साथ अटैच है, तो ये कहेंगे हम इसको ये एल्डिहाइड ग्रुप है। तो now ketones, so the functional group for this organic compound is the carbonyl carbon, and this organic compound, the functional group is bonded with carbon atoms on both sides, for examples. So in this case we can say that this is acetone in which this functional group is attached with the carbon atom on both sides. So this is a functional group attached with carbon atoms on both sides. So this is the acetone, you can say. Next one is carboxylic acid. The functional group of for these organic compounds is the carbonyl carbon COOH, and its general formula is this. So we can say this is the functional group. This is the functional group. And this is the alkyl, R stands for alkyl group. For example, so formic acid. So this is the functional group. This is the hydrogen. So acetic acid, this is the you can say the functional group attached with CH3, which is alkyl. Many then vinegar, acetic acid. So we can say orange contains acetic acids. Citric acid, you can say this is given that many salad dressing contain vinegar and citric acid. So the next one is functional group containing carbon, hydrogen, and nitrogen. So organic compounds composed of carbon, hydrogen, and nitrogen as a functional groups are called amines. The functional group for these organic compounds is NH3 group. The general formula is RNH, you can say 2. See, NH2 is, you can say amine. So, where all for alkyl group, this is, you can say this alkyl group and this is amine group. So this is methylamine. Next one, functional group containing carbon, hydrogen, and halogens. So organic compounds composed of carbon, hydrogen, and halogens as a functional group are called alkyl halides. The functional group is halogen represented by X. So general formula will be Rx, where R is alkyl group and the X may be fluorine, chlorine, bromine, iodine, for example, or X alkyl halide. So if you write CH3 instead of R, we will get this one, CH3Cl, that will be methyl chloride. double and triple bonds, double bond hydrocarbons, which consist of double bonds between any two carbon atoms are called, you can say, alkenes. So this is the alkene, for example, CH2, double bond CH2, this is a double bond between them. So this is, you can say, ethene, and propene having CH3, double bond CH2. So you can say this one has double bond and single bond. So the hydrocarbons that consist of double bonds between two carbon atoms. So this is the two carbon atoms having double bond. So this one. So we can say, so these are called alkenes. So this is propene. At the end is ENE, which is, you can say, for alkenes. So triple bond hydrocarbons which consist of triple bond between two carbon atoms. So this is the CH, this is the ethyne having triple bond. This is, you can say, triple bond, and this is also having triple bond. So one butyne, this is propyne. So here one thing is to be noted, that in case of alkane, in case of alkane, we will have at the end ANE. In case of alkene, we will have ENE, and in case of alkyne, we will have YNE. So in case of alkane, we have single bond. In case of alkene, we have double bond. In case of alkyne, we will have triple bond. So you can say that next, this is the end of the chapter. So next one is the key points. This will be discussed in next video. You can say, you can also read these key points by yourself.